Here is the 411 review preview answers. For deck session 7 said solve x minus 2 to the second power minus 3 equals 1 graphically. That is, graph y equals x minus 2 to the second power minus 3 and y equals 1 on the same set of axes. Find your x values of any point of intersection. Then use algebraic strategies to solve the equation and verify that your graphical solutions are correct. So in order to graph it, the first thing we'll do is we'll draw x, y axis. So y minus 2 to the second power minus 3. I know the vertex is at positive 2, negative 3, so right there. And then I graphed a couple extra points. I know that there's a point at 0, 1. And there's also a point at 4, 1. So when I graph the parabola, it's going to look like this. And then when I graph y equals 1, it's just a straight line. So I know graphically my answers are x equals 0 or 4. Algebraically, first I'm going to add 3 to both sides. So I get x minus 2 squared. I take the square root. I get x minus 2 equals 1, and x minus 2 equals negative 1. Sorry, 4. So 2 and negative 2. So then I add 2 to both sides. So I end up with x equals 4 and x equals 0. So I verified that my graphic solutions match my algebraic solutions. So next problem says find the equation of the line that passes through 0, 2, and 5, 2. Then complete parts A and B below. So in order to find the line, so it says, first I'm going to find the slope. So I'm going to do 2 minus 2 over 5 minus 0, which is 0. So I know the slope is 0. So when I plug it back into my y equals mx plus b, I'm going to get that. So when I plug in a point, I get 2 equals 0 plus b, or b equals 2. So if you plug it back into the formula, you just get y equals 2 as your answer. So you know that it's a horizontal line that goes through 2 every time. So part A says, what's the equation of the x-axis? Well, anytime we're drawing a line that's horizontal, we just do y. So we get y equals 0. And then the equation of the y-axis is x equals 0, because at every point, x would be 0. Problem number 10, solve the system of equations shown below. So I'm going to plug in x. So I get 2 groups of x. Eraser. So 2 groups. Off the eraser. X equals 8 minus 3y plus 6y equals 10. And then there's also, I'm going to get 16 minus 6y plus 6y equals 10. The y's cancel, so I get 16 equals 10. So there's no solution. So then A, describe what happens when you tried to solve the system. The y's canceled. So there was no solution. So then it says graph them. So in order to graph them, I put them into slope-intercept form. So this one, I end up with 6y equals negative 2x plus 10, or I end up with y equals negative 1/3 x plus 10 divided by 6 is going to give me 5/3. So then y equals, for this one, I get negative 3y x minus 8. So I get y equals negative 1/3 x plus 8/3. So when I go to graph them, if I use my graphing calculator, I end up with a graph that looks kind of like this, a little bit higher up, and then another one that looks like this. This is just a sketch. So then it says, how does the graph of the system explain what happened? So the lines are parallel. And they never cross. Okay, problem number 11, classify the triangle with the vertices 3, 2, negative 2, 0, and negative 1, 4 by finding the length of each side. So use the distance formula to find the length of each side, or the Pythagorean theorem. So I know that between A and B, it's 5 is the difference between the x values, and 2 for the y. So I get 2 squared. So I'm going to end up with about 5.39. And then for the next one, they're 1 apart and 4 apart. So 1 squared plus 4 squared. So I get approximately 4.12. And then the last one, I do A and C. So they're 4 apart, the x values, plus 2 apart. So I get about 4.48. So none of the sides are equal to each other. So I can say that this is a scalene triangle. Problem number 4-12 says examine the figures at right and then visualize the figure for end of the fourth. So in end of the 2, it's a 2 by 2 by 2 with 1 missing. 3 is a 3 by 3 by 3 with 1 missing. So then 4 would be 4 by 4 by 4 with 1 missing. So a 4 by 4 by 4 cube would be 64. And then I would take away the 1. So there would be 63 cubes. It says how many cubes are in the figure for n equals 1. So it'd be a 1 by 1 by 1, which is 1. And then taking 1 away, it would have 0 in it. So it says find the general rule. So the rule is n to the 3rd power minus 1. So it says verify with 1. So I know 1 was 0. So if I do 1 cubed minus 1, I get 0. If I do 5 cubed minus 1, I get 124. And then it says, is the sequence arithmetic, geometric, or neither? It's neither. Because no consistent ratio. And then problem 13 says simplify each of the expressions below. Express your answer as simply as possible. So for A, we would factor. So for the top one, I'm going to get 5x minus 1 times x minus 2 with x plus 4 and x plus 4 times, I get x plus 6 times x plus 4. And then I'm going to get 5x plus 5x minus 1 and 2x plus 3. Switch colors. So I can cross out the 5x minus 1s. I can cross out one of the x plus 4s. And then everything else is just left. So I get x minus 2, x plus 6, over x plus 4 times 2x plus 3. For the next problem, I have to flip the second fraction because I'm dividing. And the top one, I'm going to pull a 3 out as a factor. So I'm going to get 2x plus 1. The bottom, I can't do that, so it's going to stay 2x minus 3. Times, if I factor this one, which would now be on top, I'm going to get 2x minus 3 and x plus 1. On the bottom, I can factor out a 3 first. So when I factor out a 3, I get x squared minus 4x minus 5. So when I factor that, I get x minus 5x plus 1. So I'll change colors again. So I can cancel out the 2x minus 3. I can cancel out the x plus 1s, and I can cancel out the 3s. So then I'm left with 2x plus 1 over x minus 5. For the next part, I'm going to add. So I'm going to add the tops first and then see if I can simplify. So I get 9m plus 27 over m plus 3. So then I can pull a greatest common factor of 9 out of the top. So I get 9m plus 3 over m plus 3. So these cancel, and I'm just left with 9 as my answer. So for D, I'm going to simplify first. So 3a squared minus 2a squared is just going to be a squared. A minus negative a is going to be 2a. And negative 1 minus 2 is going to be negative 3. All over a squared minus 2a plus 1. So then I factor them. So I'm going to get a positive 3 and a negative 1 for the top. For the bottom, I'm going to minus both of them. So the a minus 1s are going to cancel. So my final answer is just a plus 3 over a minus 1.